Good morning, students.
Good morning, ma'am.
Do you have any doubts from our previous class? Did you study it? Students, today I'm going to give you an assignment. Please complete it. We have started with this register, transfer, and micro operations. Yesterday we have done register, transfer language, register, transfer. From bus and memory transfer, we have to do yet another topic. So this is not done. Today we'll try to finish these three topics. So you are supposed to write assignment. I will mark here the questions. Here, this 18th, you are supposed to write answers for 18, 19, 20. These three questions you have to write answers for. Again, I'm asking students, do you all have any doubts in our previous class topic? Oh, very good. Fine. Then we will move ahead to the other way to create a bus system is using three-state bus buffer. One way of doing it is using multiplexers. We have created a bus using four by one multiplexers for 4 registers, each having 4 bits of information. The other method for developing a multiplexer is by using a 3-state bus buffer. This is the graphic symbol for 3-state buffer. What is it? What is a buffer? Essentially, a buffer is a place, is a gate. It is a gate which uh, generates the same output as that of input. This is the graphical symbol for buffer gate. This is known as buffer gate. If you, this is x is the input, f is the output. Can anyone tell me now what is the value of f when x is 0? Can anyone tell me what is the value of f when x is 0?
0.
Very good. It is 0. What is the value of f when x is 1?
1.
1. Very good. So what does it means? It means that buffer gate is taking the input and generating the same thing, identical input as output. Okay, so this is our buffer gate. What is the difference that you see between this gate and this gate? Do you see any difference? Here this notation is same. There is an input, there is an output. What is extra here? Extra is the control input C. Here you don't find C, control input. Here you have a control input C. What does control input C does? It controls the output. It is like a switch. You might have seen like this. You have a switch that connects this circuit. When the switch is, switch is open, you can also have this switch closed. Okay, this is closed switch. When the switch is open, from here to here there is a break in the path, and therefore the signals won't travel from this. Consider that this is A point and this is B point. From A to B, signals won't travel. When the path is closed, when the signal is closed, a path is established, and from point A to point B, signals will flow. Here also you have this control input C. This control input can be closed or open. Here it will be like this when it is open, when C is open, or you can have in this manner when C is closed. This is C. This here C is open and here C is closed. C is closed means what? C is 1. There is a path. When C is 1, here, what happens is this input will flow from this buffer gate onto the output line. This output line will take on the input when C is 1, means in this manner, this one. This is C is equals to 1. When C equal to 1, Y is equal to A. What is Y? Y is here output. What is A? A is the input. Remember, you can give any names for input and output variables. Here it is given as Y and A. You can as well say X and F. You can as well say Z and W. You can give any names. Y denote output here. A denotes input. Output is equal to input when C is 1, and the state in which C is open means there is no connection here, then it is known as high impedance state. Apparently, the input won't travel to the output, and it results in a high impedance state. That state is known as high impedance state when C is 0. Do you understand this three-state buffer? This three-state buffer is now used in the combination with other three-state buffers to create a bus. Recall that bus is a common structure that takes input from various sources and then chooses any one source and sends that data onto the line, that the channel which carries the data, and eventually delivers to the destination or the destined register. That is a bus. Earlier we constructed bus using multiplexers. We took 4 multiplexers. A multiplexer is a circuit that takes n inputs and generates one output. In our example, we had 4 inputs and there was one output. These 4 inputs were connected to 4 registers named A, B, C, and D. And this multiplexer 0 connects 0th bit of all 4 registers. This multiplexer 1 connects first bit of all 4 registers. Likewise,
Ma'am,
yeah.
uh, few students wants to join. Please let them in.
Yeah. This was created through multiplexers. Now we will create the bus structure through three-state bus buffer. Three, this one is three-state bus buffer. Three-state buffer. All right. Now there is a question to you. Can you tell me? Can you tell me, students, for creating a bus to carry 4 bits, how many three-state gates are required? To create a bus to carry 4 bits of information, how many three-state gates are required? That is the question. let us discuss. Here we are, this please understand here that this three state gate, this is a three state gate. This three state gate will carry one bit, all right? And then we there are four registers, and each register has 4 bits. This one will carry just one bit. This three state gate, another three state gate, another three state gate. So these four three state gates will carry how many bits? Actually, they carry one bit. Why they carry one bit? Because they are combined. Why they are combined? We'll see now. This line, this is the like this. Uh, this one is there, no? This is zeroth line of the bus. Here we are creating zeroth line of the bus. If you relate these two, you will understand that this one multiplexer took 4 inputs and has produced one output. Here, to simulate the same kind of behavior where you are creating one bus line, you need to have 4 different three-state buffers. Each one would be connected to the one bit from every register. Here you see how this is connected. This A naught, this is B naught, this is C naught, and D naught. This mux 0 would connect 0th bit of all 4 registers. Likewise, these 3 state buffers connect A naught, B naught, C naught, D naught. And from these 4 buffers, we could generate one line for the bus system. Likewise, we have to have further 4 three-state buffers to connect A1, B1, C1, D1. And then this would yield our this part. Another line, first line for the bus system. This is 0th line for the bus. This is first line for the bus. Like that, you have to have A2 up to D2 that would connect, that would create this second line for the bus system. Finally, A3 to D3 A3 to D3 would connect and create third line, which is analogous to this third line of our common bus system. Here, what is the mechanism that would 1 minute. What is the mechanism uh, that is taking 4 inputs and generating 1 output? That circuitry is known as a multiplexer. Multiplexer is a circuit that takes n inputs and produces 1 output. Here you don't have such facility in this 3-state buffers. So you have to include decoder. And in multiplexer we had select input lines S1 and S0 to choose any one input to be forwarded on the output. There was this selection lines. And here in 3-state buffers, you don't have such selection input lines. Therefore, you need to resort to decoder. Decoder is another circuit. In this circuit, it takes n inputs and generates 2 to the power of n outputs. What does decoder do? A decoder is a circuit that takes n inputs and how many outputs it generates? It generates 2 to the power of n outputs. All right. Like multiplexer, you also have another kind of circuit which is known as decoder. Decoder would take n inputs and generates 2 to the power of n outputs. Let us visualize this and see how it. A multiplexer is this circuit that takes n input and generates only one output. And to choose which input to be forwarded, whether this input to be forwarded or this input to be forwarded or this input to be forwarded, that is decided by the select input lines. Okay, now decoder. What does decoder do? It is also a circuit and it takes n inputs. If there are If n is 2, how many outputs decoder will produce? Can anyone tell me?
2 power n.
2 power n.
2 power n, very good. 2 power n means here n is 2. So what will be the value?
4.
Yes,
Roughly.
4. 4. So how many outputs you get here? 4 outputs. Okay. And here you can also have a here okay, here there is like a switch. You can have a switch which is known as enable. When you might have seen a fan, okay, you have this fan. How do you operate this fan? You operate this fan using a switch on the board. On this electricity board you will have a switch, and also you also have this regulator. There is one regulator board, and now you are getting very small regulator. Here 1, 2, 3, 4, 5 speed levels will be there. So how do you operate this fan? You can put this fan in on state or off state. When this fan is in on state, here you can regulate generally 5 speed levels: 1, 2, 3, 4, 5. Okay, this is like a switch. In this switch, when you on it, further you have another switch which is called as a regulator. You can operate the fan at different speeds. Likewise, for a decoder, also for multiplexer, for any electronic circuit, you can have a switch which is known as enable input. If this enable input is 1, the circuit will operate. If enable is off, circuit will not operate. Students, if the fan is off, in off state in the switch, can can you change the speed levels? Yes, you can. Even then there is no effect on this. Will there be any effect? No effect. If fan is off and you move this regulator to a speed 5, even then fan is off. You again regulate it to 1, even then fan is off, because it is in off state. This regulator functions only when the switch is in on state. Likewise, you also have an enable input. Enable input regulates or controls the circuit. Well, this enable input is like a switch. When it is 1, it is like on. When it is 0, it is like off. When I give inputs here for decoder, let us take x1 and x0, two inputs, and d3, d2, d1 and d0, four outputs, because here we are considering n is equal to 2 and outputs will be 4, because it is 2 to the power of 2, which is equal to 4. If they are 0, 0, what is the value here at the input? It is 0. So the 0th output would be 1. If it is 0, 1, what is the input value? Decimal value I'm asking. When you convert this binary into decimal, this turns out to be 0, this turns out to be 1. So this D1 this output will generate 1, remaining other outputs would give 0 as the output. When the combination is 1, 0, D2 would produce 1, remaining would be 0 because the decimal equivalent for this is 2 and this D2 would be 1. Here this is D0, D1, D2, D3. This would be X0, X1. And when both are 1, 1, D3 would give 1 as output, remaining 3 outputs would be 0 and this implies that it is equal to 3. This is how decoder operates. And this decoder, like these inputs here are known as, yes, anything? Yes, Pavan?
Ma'am, I have a doubt.
All. Yeah, please go ahead. What is your doubt?
Ma'am, I couldn't get that conversions.
This conversion you did not get? Okay, I will
Ma'am,
explain
this
you.
how X0 and X1 values are changed into D0 to D3.
Okay, how they are changed? They are changed because uh, here this you create decoder is a circuit, right? It is an electronic circuit. So how do you create? Using AND gates. How do you make D naught 1 when both are 0 0? When both are 0 0, you have to use inverter. This is X naught and X1. When you are passing both to be 0 0, they become 1 and 1 and this D naught would give you. This is how decoder is constructed. This is internals of a decoder, what I'm showing you now. This is the overview and this is the internal detail. When D1 would give 1, when X naught is 1, so X naught is 1 means you just pass direct as X naught. You don't use any inverter. When do you use inverter? When you have to change the value. Consider that X0 and X1 are input values. When they both have 0 0, you want output of D1 to be equal to 1. How do you ensure that output of D1 is 1 when both are 0 0? If you convert both 0 0 into 1 1, then you can ensure that D1 would give a value of 1. How are you doing that? By using an inverter here. This is an inverter. Inverter you can write in two ways. This is an inverter, or you can just use a small bubble as inverter. This is how you ensure that when the both are 0 0, you D0 would produce value 1. When X1 is 1, no, X0 is 1. Suppose now here X0 is getting 1 and X1 is getting 0, but you want D1 to produce 1. When X0 is 1 and X1 is 0, you want D1 to produce 1. So how do you ensure that? If you put a inverter at X0 side, this is X0. If you use this inverted value, then you can get here 1, right? Okay. A little bit at least, is it making sense to you? If it is not making sense to you, what I would do is I would send one more link for decoder today, a video link. You can go through that, and still if you don't understand, then you can further ask me in the upcoming classes. Now just try to understand that decoder would generate a 2 to the power of n outputs given n inputs. And how it generates these outputs, you have to map. How do you have to map? You have to ensure by using some other gates such as inverter gate to have this kind of output given this input. Consider that when this is the input, you should ensure that you get this output on this side by using inverter gates. Likewise, you have to use here when x naught is 0. X naught is 0 means you have to use inverter, and x1 is 1, direct connection you have to use x1. Here both are 1 1, so direct connection you can use without any inverter. Then this will give, T3 would give 1. Okay, no, please don't worry. I will share a video of this decoder today. Please go through it. Still, if you don't understand, you can ask. Let us go ahead and complete this bus. So here we have a decoder. When both the values are 0 0, decoder here would give 1 at this side. When this decoder would give 1, a naught would be selected, because when this is like control input, when this is 1, this would be closed and all others would be 0, so this will be open. When this is open, they are in high impedance state. Because this is closed, the input from a naught will travel onto this line. This decoder is connected to more 12 three-state buffers. These are only 4. These 4 would form just one line, bus line for bit 0. For bit 0, this is the bus line. Like that, you have to complete this figure for bit 1, for bit 2, and for bit 3. How do you do that? This decoder remains same. This decoder would connect to and let us name these three-state buffers. If these three-state buffers are 0, 1, 2, 3, then here you will have 4, 5, 6, and 7. This 0 input, 0 output of decoder would be connected to 0th buffer, 4th buffer, 8th buffer, 12th buffer. The same line would go in all the buffers, and then when both the inputs are 0 0, the output from 0 would be 1. When the output from 0 is 1, these bus buffers would take data from register A. This side, from this section, you are taking A naught. Another, this section you take A1 and A2, finally A3. So you are trying to take the bits from register A when S0 and S1 are 0 0. Does it make sense, students? Okay, this memory transfer we will learn tomorrow. I mean next class. Today I will try to somehow make you understand this. All of you do one thing. Create, complete this figure. Please sit with a pen and book. Take pen and book and complete this figure, all of you. Have you started doing? Meanwhile, those who did not understand decoder, let me go through the decoder concept. Okay. Students, those who did not understand decoder, please look at this figure. This is a 3 by 8 decoder. This is also known as 3 to 8 line decoder. You can write this in this format, N to M line decoder. You can write 2 to 4 line decoder, 3 to 8 line decoder, and 4 to 16 line decoder like this. What is the goal of this circuit? The goal of this circuit is when all the three inputs are having value of 0, 0 and 0, D naught should produce 1, all the other outputs should be equal to 0. Okay, that is the goal. How do you achieve that goal? Now, you know that these three inputs are having a value of 0, 0, 0. If you apply an inverter at the input side, this 0 would turn to 1 and this also would turn to 1, and here this way it is, this way, look at here, this way it is 1, and then you are passing this here and this one here, this one, and this is this. You are converting these zeros into ones and giving ones as input to this AND gate. This is an AND gate. Then what happens? Obviously, D1 would give a value of 1. All the others would give 0 because it is AND gate. AND gate would produce 1 only when all the inputs are 1. If any one input is 0, the output would be 0 irrespective of the total number of ones. You know, if there is 1 0 and all others are 1, even then the output is 0. We know that these three are zeros. Look at here, what are you doing? Here you are connecting to 1. Here this connection is giving a value 1 for A2, and this connection also would give a value 1, whereas carefully observe, this connection would give a value 0 because you are not using any inverter, directly you are applying as input to this. Because of this, this would give 0. And if you uh, cross check every connection here, you find that when the three inputs are 0, 0, 0, only D naught would produce 1, remaining all would produce 0, because one or the other connection would be having 0. This also is your assignment today. You please construct 2 to 4 line decoder, 3 to 8 line decoder, and 4 to 16 line decoder. Then try to understand how connections are being given such that only one gate would give 1 at a time, remaining all gates would give 0. Until and unless you sit and solve, you won't understand. This is like mathematics. If you solve a problem, you will get to know the intricacies. Like that, for today, I am writing here, all of you are supposed to do, today is 19/1/21. First thing, start writing your assignments. Write question number 18, 19, and 20. Question number 2 is construct a decoder for 2 to 4 line, 3 to 8 line, and 4 to 16 line. Third is complete the figure of bus system constructed through three-state buffer. These are the three tasks which you are supposed to do, because again I would be taking class perhaps next week, or this week one class I may take, but then actually next week I would take. Every week you have two classes. So these things you have to complete in 2 days. Suppose if I take on Friday, then I would check these three things. Okay, students, any doubts? Have you started doing the work? Can anyone give me response?
Ma'am,
Yes.
ma'am, is that the first assignment is like questions answers?
Yeah, question answer. Questions are here. I shared with you all. Here. This one. This course file I have shared, no? In the course file, in the Google Classroom also you have this course file, and in WhatsApp also I have shared with you all. This is my course file. My means our course file for computer architecture subject. All the details you will find about this subject in this. You also have question bank. From this question bank, you have these 18, 19, 20, these three questions you have to write. Answers you have to write for these three questions. You have got the textbook as well with you, so you can write that. Anything else?
Ma'am, we have to write and submit to you, right?
Yeah, you have to write. In a one long notebook, maintain one register. Okay. So let us talk in CA terminology. Maintain one register, one long notebook. You have to go on writing whenever I tell you. Every class I will, from now onwards, every class I will give you assignments, one or two questions. Finally, you have to, if in case contact classes won't begin, you have to scan that and upload. Or if contact classes begins from 1st February, I will check your notebook and I will correct. Okay, students?
Yes, ma'am.
Did you all understand? Have one separate notebook for computer architecture. One side you write class notes, other side you write assignments. Any other question you have? Because I have given you the task now, you please complete the task. I am leaving you for today now. Anything if you want to ask me, because if you start doing on your own, you will get many questions, then I can address those questions.
Ma'am, we have to finish this assignment within this week now.
Yes, within this week you have to finish. Actually,
Okay.
not within this week. Friday you have to show me.
Mm.
Are you finding it difficult to do? Only three questions, no? Three questions and more two are there. Uh, if you can't complete, then we'll see. But as of now, the date for submission is 22nd of January. Okay, then students, all the best for your assignment.
Ma'am, can you upload today's session, ma'am, if you don't mind?
Yes, sure. I uploaded yesterday's also. Today's also I will upload.
Ma'am,
With
I've checked in the YouTube, ma'am. The link that you have provided, I didn't see yesterday's.
yesterday, uh, when did you check, Sai?
Just early in the morning, ma'am. Today at 8:45.
Today only I uploaded. Today
Okay.
8:45. Again, otherwise you subscribe whenever it gets uploaded. Automatic notification you get.
Yep, sure, ma'am. Thank you so much.
Okay. Okay, students. All the best for your assignments. Bye bye.